So, over the last few days, we've been factoring, and lately we have started studying the solutions of quadratic equations. So today what we're going to do is we're actually going to take a look at a quadratic equation and learn about the number of solutions for a quadratic equation. Now, let's go over some preliminaries. 1. Basically, you know what a quadratic equation is. A quadratic equation was anything in the form, and we knew that in order to find solutions, we originally had to factor, or using the quadratic equation, which is x equals negative b plus or minus the square root of b squared minus 4ac. And we referred to this part of our equation as the discriminant. Now, you recalled a couple days ago when we were doing our use of the quadratic equation. When we did our substitutions, we had negative b plus or minus the square root of b squared minus 4ac all divided by 2a. This entire problem was predicated on the fact that this plus or minus gave us two solutions. But today I'm here to tell you that the discriminant gives us literally three possibilities. Now, the three possibilities are this. The biggest issue is the square root sign. Now, remember I told you you had to always calculate the discriminant, the stuff that was underneath the square root sign, in order to do quick calculations for your solution. Well, I was hiding the fact that this is the case. If you think about it, the entire problem is based on what's underneath the square root sign. This discriminant tells us things about our quadratic. Now, if our quadratic, when we calculate this, if we look at just this stuff underneath the square root sign, the plus or the b squared minus 4ac can have the following. If that b squared minus 4ac is greater than 0, then we literally have two solutions. So you'll have x equals some number and x equals another number. Now, if b squared minus 4ac equals 0, then we have one solution. And if b squared minus 4ac is less than 0, then there is no solution. So for this lesson, this quick lesson, we're just going to have three different equations. For our first example of problems, we're going to have these three equations. And for the first problem, we need to identify the a, b, and c. Let's do that for 2x squared plus 5x plus 3 equals 0. And now that we've done that, we need to look at the discriminant if we need to know the number of solutions. Remember, roots are the same thing as solutions, so all we have to do is use the discriminant. So 2. Start by writing your discriminant, b squared minus 4ac, and then what we'll do is we'll substitute accordingly for a, b, and c. And now we'll quickly expand. So now we have 5 squared is just 25. And then to get rid of all of these brackets in the last part, think of it as negative 4 times 2 times 3. Using your calculator, negative 4 times 2 times 3 is negative 24. 25 minus 24 gives us 1. So now we say Therefore, the number of solutions is 1, or you could replace solutions with the word root. The number of roots is 1. Now for question B, we're going to do the same as we did before. Step 1, identify A, B, and C in our equation. And we get this for A, B, and C. Notice there's no number in front of x squared, which means our value for A is 1, and B is -10, C is 25. Now, since we need to know the nature of roots, also known as the number of roots or the number of solutions, what we can do is we start by using our discriminant. Now, in making appropriate substitutions, we get this. Expanding, we get the following. Wow, and now it says our discriminant is equal to 0. So what you need to think of is, imagine if 0 was inside this bracket here. What is the square root of 0? 0. Plus or minus 0 is still 0. So technically, when you plug this in to your solutions for your quadratic equation, you're going to get exactly one solution. One solution, or also known as one root. Therefore, there is one solution or one root. For the last problem, for our first example, we have x squared plus 36. Pause the video, try this solution, and then we'll see what we get. So for this problem, we had a small trick. You notice that there was no b term, so we must say that our b value is 0. A is still 1, and the final value, c, is 36. Now what we'll do is we'll do our discriminant. So now we're going to get 2b squared minus 4ac. Substitute directly in. B is 0 squared minus 4 times 1 times 36. Now, 0 squared is 0 minus the last half is 144, which is negative 144. Now, if we continue referring back to our ideas of the discriminant, you'll notice that b squared minus 4ac, the answer is less than 144, so therefore there's no solution or no roots. For example 2, we're going to have some algebra that we're going to deal with. So this problem asks, for what values of k does the equation of k squared minus 4x plus 9 equal 0? Now, another way of describing have only one solution is you could say 2 equal roots. So remember before we said the discriminant was b squared minus 4ac, and we knew the following about it. And we have these properties. B squared minus 4ac greater than 0, 2 solutions. B squared minus 4ac less equal to 0, 1, and then b squared minus 4ac equals 0, no solutions. In this case, we're looking for one solution. So we're going to take a look at our original equation. Let's identify A, B, and C. Now let's do our appropriate solutions for the discriminant, because we need to know the number of roots. Since we know the number of roots is 0, we're going to have to use this equation and we'll see what we come up with. This is kind of hard, so be careful. So we'll write b squared minus 4ac equals 0. The next stage is we do our substitution. B squared is negative 4 squared minus 4 times, well, k times c, which is 9. Now notice how I keep my equal signs lined up and my substitutions are on the left side right now. Now let's continue by getting rid of the brackets. Negative 4 squared is 16. So now this entire last half, it's negative 4 times positive k times positive 9, which gives us the following, negative 36. So k. So now 16 minus 36k. Let's go and isolate the 36k. So I'm going to take my 16 and move it to the other side of the equation. So now we have this. And now we'll simplify. And now we'll divide both sides by negative 36 to get k by itself. And this is our final solution. K equals negative 16 over negative 36. Simplifying that, reducing our fraction, we get 4 over 9. Homework for today is page 17, number 1, 2, 3, and 7. Remember, that's your homework.